In questions 1 through 4, it says they want you, we're not gonna graph these. We just wanna test to see if they're symmetrical to the x-axis, the y-axis, or the origin. So, for the x, I always think of opposite, okay? So if you're testing for x-axis, what you do is you replace the y value, you're gonna put negative y. So you're gonna have negative y equals x squared plus 2. Now, if you multiply this whole thing by negative 1, you get y equals negative x squared minus 2. Could we get this in back to its original?
No.
No. So is this symmetrical to the x-axis? The answer would be no. How about the y-axis?
Yes.
Why is it yes? You
Because
replace,
we replace the x with
yep, you're gonna replace x for negative x, and you get the same answer. So does this have symmetry to the y-axis? The answer is yes. What about the origin? What are you gonna do? The origin, you're gonna put both. You're gonna put a negative y here and a negative x here. So the origin, sorry, there's not a lot of room. You're gonna put negative y equals negative x squared plus 2. Is this gonna go back to its original? No. So this would be no. By the way, just to review, if I asked you, are any of these odd or even, you would say it's even. Even means symmetrical to the y-axis, right? How about number 3? Number 3, you've got y equals x cubed plus 2. How do you test if it has symmetry to the y, the x, let's do x first. X-axis, what do? You're gonna replace y, you're gonna write negative y. Is this one a yes or a no? This is a no. How about the y-axis? For the y-axis, you're gonna replace, for x, you're gonna put in a negative x. And it's x cubed, by the way. It's hard to see that. And this would be also a no. How about the origin? You're gonna replace for the origin, you're gonna replace for y, negative y, and x, you're gonna put negative x. And this is also gonna be a no, because this is gonna be negative, this is gonna be negative, and when I multiply the whole thing by negative 1, you're gonna get y equals x cubed minus 2. So this would be no. Does anyone have questions on that one? Okay, number 7. This is strictly asking you, determine algebraically whether or not the graph is symmetrical to the y-axis. What do you do for y-axis symmetry? You replace x for what? Negative x. So, right here you're going to have negative x squared plus y squared equals 1. Does this one work? Is this a yes or a no?
Yes.
This is a yes. How about number 9? We're going to do 9. We're testing for y-axis symmetry, so we replace x for negative x. You're going to get 4 times negative x squared minus 3y plus y squared equals 7. So on your test, this is what you're going to have to do. You're going to have to show me. I know some of you guys can do this in your head, but you're proving, this is like an algebraic proof. So you get 4x squared minus 3y plus y squared equals 7. Is this a yes or no?
Yes.
This is a yes. Okay? So what are you noticing about these? If you could do a shortcut, even though on your test you're not going to do that for me, what would you say? To test for y-axis symmetry, what are you noticing that both of these have both of the, they're even, right? The x powers are all even. If you had an odd one in here, like the x to the first power, it would be a no, it wouldn't work. Okay, 11 through 14. It says determine algebraically. The algebraic way is when you replace x or y or both. In this one, they want you to test for y-axis, x-axis symmetry. So what do? You take the y value, and everywhere you see a y, you're going to put in a negative y. Okay? So looking at number 11, what are you going to do? You're going to write x squared minus 6x. You're going to put in a negative y here and square it. Is this one going to be a yes or a no?
Yes.
Yes, because this is going to go back to y squared. So on your test, this is what you would do for me. And that would be, you would circle, it's going to say yes or no, and you would say yes. Real quick, what would 12 be without doing it? Would 12 be, it would be a yes also. How about 13? What's 13 going to be?
No.
It's going to be a no. Why is it going to be a no? Because right here it's going to work, right? But right here it's not. So what you would do on your test is you would show me this. You would write plus y squared. You'd write minus 2y here. And then what you would do is you would multiply everything by -1, or you could just say no. I would know that you know that it's a no. And this is a no. Is everyone okay with 13? How about 14? Would you say yes or no?
No.
It would be a no because of that odd y. Okay. 15 through 18, they want the origin. What do you do to test algebraically for origin? You do x, you're going to put in a negative x, and a y, you're going to put in a negative y. So what you have here is 4 times negative x squared minus 3 times negative y squared, and then plus negative x times negative y equals 6. Let's see what we have here. We have 4x squared minus 3y squared plus positive xy equals 6. Did that go back? So yes, that would be a yes. By the way, what's another name for origin symmetry? Odd. And I remember OO, odd origin. What do you think that one's going to be?
Yeah.
It's going to be yes because they're all odd. And when you replace them, they're all going to be negative, but then when you multiply them all by -1, it's going to be, so this would be a yes also, without doing any math. What about this one? If we do absolute value of negative x plus the absolute value of negative y equals negative x squared plus negative y squared, what's the absolute value of this? It's going to be a positive. And this is going to be a positive. And this is going to be a positive. And this is going to be a positive. This one, the absolute value of negative x is x. So this one, I would say, this one, I am drawing a blank.
Yeah, but I want to be carrying that.
Yeah, I'm not really sure what they want us to do here, so let me look this up. 3.4 A. This is number 17. Number 17. Yep, it is. It's yes. So this is a yes. And 18 is 18. This is going to go positive. This is going to be a A what? This one would be a what? I'm gonna say no. Let's do it. 3 negative x squared equals 4 times negative y minus 2 times negative x, and then plus 6. So we get 3x squared equals negative 4y plus 2x, and then plus 6. This is gonna be a no. Because you're gonna get a negative here, a positive here, and no, this is gonna be a no. This is a no. Okay, now, the back page. Now we have to test by looking at the picture. We want x-axis symmetry, y-axis symmetry, x-axis symmetry, and the origin. So, what I would do is for y-axis symmetry, let's do that first. If you were to cut number 19 along the y-axis and fold it over, what's going to happen? This would be no for y. How about the x-axis? If you were to fold this along the x-axis, it would be a no. So we'll say no y, no x. What about the origin? It's a yes. This one is yes, origin. Because if you look at, pick a point here. This is, first of all, do you know what the equation of this is? Do you know what the equation is? It's y equals negative x. For every y value, it's the opposite. If you looked at any point here, I mean, what they should do is give you like some numbers and see that this one has, for every x value, that the x value is going to be the opposite on the other side. So if this ordered pair right here was 3, negative 2, check to see if negative 3, positive 2 would be, and that would be that point right there. Okay. Number 20 going down. Somebody colored this. This that has nothing to do with. Yeah, I know. I'm sorry. What would you say for 20? X, Y, and origin. If you were to pick a point here and draw a line through there, these would be the same. These would be the same. Every point that you pick, you'd have, if you change both the signs, it would be there. So yes, this is all 3. This one's all 3. Number 21, what would you say for 21? It's one of them. If you cut this on the y-axis and folded it, it doesn't work. This little bump right here would be right here. The x-axis, if you were to fold this, this would be down here. So no. So no x, no y. But the origin, yeah. If you took a point, like pick this point right here, if you were to draw a line through here, these two would be the same. And this point is the x and the y are both opposite, so yes, origin. Are you guys getting this? Mm-hmm. Okay. How about 22? What would you say for 22? How about the y-axis? If we were to take this and fold it along the y-axis, check this out, yes. This would be y-axis symmetry. How about x-axis? If you folded this along the x-axis, this would be no. X is no. How about the origin? Pick a point. If I were to pick a point right here, no, it would be right about there. So this would be no origin. 2 more. What would you say for 23? That's an easy one. That's with respect to the y-axis only. Y-axis only. And how about 24? All of them. Good? Okay, 25 through 29. Instead of using x-axis, y-axis, and origin, they use the word even and odd. Neither means it's not even or odd. Neither means not even and not odd. Well, what does even mean? What is even? it's y-axis. So what you do for that is you replace x for negative x. And for odd is origin. So you do x and y. So if it's not symmetrical to the y-axis or the origin, that's when you say neither. It's neither odd or even. Okay, not at, it doesn't mean x-axis, okay? So for 25, what would you do? You have y equals 4x. If you replaced, first of all, for y-axis symmetry, you replace x for negative x. Would that one work for even? It's not even. So you would do this, 4 times negative x, and that would be a no. So it's not even. But for odd, you would do negative y equals negative 4, will actually be 4 times negative x. Which if you multiply both of these by negative 1, you would get y equals 4x. So yes, this one is origin. So it's odd. This is an odd. 25 would be an odd function. What about 26? I believe it says it would be, think of it as y equals negative 5x, even though they use 2 different letters, but that's what they're asking you to do. So it's asking you if you plugged in for y-axis symmetry, you plug in x for negative x, and this would not work. But what about the origin, if you made them both negative? And that's because they're both odd. It would be an odd function. Because it has if you put a negative y here and a negative x here, you can multiply them and then you'll go back to the original. Okay? How about 27? If you replaced x for negative x, you have y equals x squared minus the absolute value of x. So you're going to put in x, you're going to put in a negative x. You're going to go back to its original. So this one's going to be even, but it's not going to be odd. Odd will not work. For 28, this is saying if you want to replace your variables for x and y, this is what you have here. For 28, 28 is going to be an even function because when you put a negative x here and you take the absolute value of it, it's going to be positive. So this will be even, but it will not be odd. And for 29, this is hard to read, guys. Y equals, I think, you know what, I think it says it's going to be x to the 4th minus 6x squared plus 5, even though they use t. This is an easy one. What would this one be? Odd or even? Or neither? Neither? Why not it's even. It's even. Because if you put in x for negative x here and here, these are going to go back to positive. So this is going to be even. It won't be odd because when you put a negative y here, you'd have to, and a negative x here, you'd have to multiply. It won't work. So 29 is even. Okay, the last 4 problems are asking you to complete the graph. If the given function is even, what does even mean? So what would you have here? You would take these ordered pairs. So let's call, what would you call this point right here? This would be 1, 2. And let's call this 3, 3. Actually, 1, 2, 3, 3. This is hard to see. 3. We're going to say 3, 3. How would you make this even? What would you have to do to these 2 ordered pairs? Change the what? Even, you change the x value. So you would graph -1, 2. which would be, I don't know, that, and negative 3, 3, which would be that. So how would you make this an even function? Does everyone get that? You take your x values and change their signs. How about 37? How would you make this an odd function? I would take these points right here, maybe take, I don't know, 2 or 3 of them. Oh, these are hard to read. But whatever these ordered pairs are, let's say this is 2 comma negative 2. Let's say that's 2 negative 2. And let's say this is 3 negative 4. I'm just guessing. Would you agree? You're going to take both of these ordered pairs and change both of their signs. So you would graph negative 2, positive 2. And you would graph negative 3, positive 4. And what your graph is going to look like is, it's going to be hard to see. It's going to be like that. Okay? For even means across the y-axis. So again, take all your ordered pairs. Your graph's going to look like this. So take these ordered pairs and just change your x's. And then for the last one, odd, take these ordered pairs and change both the signs, and it should look like this. So if this ordered pair is negative 1, negative 2, negative 3, negative 4, this is negative 5 comma 0, you're going to graph 5 comma 0, if that's 5, 0. If this ordered pair is negative 2, negative 2, you're going to graph 2, 2. Does that make sense?
Yeah.
You change both of their signs.
Cheers.
Colin?
Cheers.
Hit feet.